Hello, everyone, and welcome to the presentation. I'm honored to speak in this forum today. Thank you, PMI, for this wonderful opportunity. I'm Ruma Mukherjee, Chief Architect of Unisys. I technically lead the Emerging Technologies vertical in Unisys. Today, I will speak of my experience in the journey of setting up the AIML COE in India and how we grew up to be a full-fledged organizational unit in over around 1.5 to 2 years. I will talk of the various best practices we follow and some of the important learnings in the process as we grew up to be a successful unit in a very short span of time. So I was working as a software product architect, and one fine day, my boss calls up and tells me, Ruma, you are selected to lead and build the AIML COE in India. Now, AIML being a very high-rated buzzword, I was super excited. But she also added, please remember, we have to show results pretty fast and deliver. And that was scary, that word, deliver. Right. I soon figured out that our company has lots and lots of data and they wanted to get some meaning out of it. But where do we start? We did not have a proper team to start with, no proper use case, and no infrastructure or understanding, and everything was so very undefined. Only one thing was fixed. We have to show quick results. I just did some quick research and found out that Gartner CIO research reports that more than 50%, let me repeat, more than 50% of analytics projects fail in the real world. It is not a very encouraging note to start with. And the research said that the two most important reasons of failure are we often focus on analytics output versus the business outcomes. That means the development teams always tries to focus on the accuracy of the models, the RMSE, X, Y, Z, all the technical metrics instead of focusing on the business outcomes. Another reason was we focus on tools and technologies without aligning to the business decisions. So we think of using GPU, we think of using the PaaS services without understanding whether the business is ready to afford that much money or not. Hence, these were the most important reasons why AIML practices often failed. Hence, we are often drowning in data and starving for knowledge. So with these studies, I kind of started understanding what are the all things that we should not do? Good, at least I understood something. And then I started with building up the architecture first, because as I said, that's where my expertise was as a product architect earlier. That was the beginning of my journey. That's what I'm going to talk today. First, architecting an AIML platform that should be reusable for solving multiple use cases from different domains and different problems. I will carry on explaining the few of the processes which AIML development teams like us normally adopt in their journey, and very importantly, the quality assurance guidelines. My entire presentation is a snapshot of our learning as we sailed through the process of setting up the COE for AIML in the organization. Let's start with the AIML reference architecture. What do we see over here? Can we see the chaos created by the n number of jargons which are associated with machine learning? It's just a small subset from the confusing and complicated world of AIML. So how do we understand what is what over here? So that is the entire purpose of a reference architecture. It was a plethora of tools, technologies, data science concepts, terminologies, along with the volume and the variety of the data and its understanding that was making the adoption of AIML quite daunting. And here is the approach which we adopted. The end-to-end AIML solution platform was decomposed into 5 stages, with each stage having its unique set of challenges and with respect to the capabilities, interfaces, topologies, tools and technologies, scalability, security, etc. Reference architecture is the technical blueprint. It is a technical blueprint providing validated and useful guidance, standard, and best practices in all these 5 stages. Let me quickly brief what the 5 stages are. First is data ingestion. This is the first stage, which talks about the ETL practices for high volume of a variety of data into the platform in a secured and scalable way. This stage also talks of the design principles to store data in different storage infrastructures, like SQL and the NoSQL data stores, creation of the data lakes, provisioning for discovery, governance, and serving the right data in the right way to the right people, mostly the RBAC kind of things. Parallel data ingestion, data encryption techniques, and distributed storage systems are some of the design challenges over here. The second stage is the data pre-processing. This is a very, very important stage after we gather the so-called big data. This stage mostly consists of the data understanding part, the data analysis and the feature engineering before the data is ready for modeling. The computation requirement at this stage is the highest because it's the raw data, there is no filtering, this is the entire data set, and we normally need large-scale distributed processing like the Spark clusters instead of personal laptops. The third stage is the model engineering, which is when the data scientist actually sits with the data, tries out multiple models to fit into the data, trying to best fit a particular algorithm. So depending on how complex the ML routines are, the execution environment over here often consists of high-performance clusters and the GPU machines. Fourth stage is the execution. This is the stage, it's kind of a staging environment where complete end-to-end integration testing is done in production-like environment so as to validate the model in a real-life scenario. And of course, the final stage is the deployment stage, where models are deployed as a separate entity or as a part of a bigger product or with a simple API-based solution. So multiple deployment possibilities and challenges are addressed in the reference architecture to provide the right guidance to the DevOps engineers or the new use case implementers. That's all what the reference architecture is all about. So let me just tell you that we adopted the Gartner suggested style of the reference architecture. And yeah, so now we have something to start with. Excellent. Okay. So here I have listed some of the benefits of the reference architecture more formally and why it is important and a must-have for any organization which is starting with the AI/ML practices. So some of them are the generalized solution to reduce the complexities of the design and the implementation for specific use cases. It's a generalized solution kind of. It gives you the reusable, repeatable, predictable components, patterns, and the best practices. It gives you the insights which you learn throughout your experience. It provides you the optimized infrastructure and, of course, a common language to speak of. So the basic idea is that now we have a comprehensive, focused approach with proven tools and techniques. So step 1 is done. Now what? So the next challenge was to bring in more structure to the problem solution space in alignment to the industry best practices. We started with our next journey, framing the problem and planning the work. Remember that we have to deliver. So it is no more a research organization. We have to deliver, and without proper planning, things normally takes lots of time. So we started defining the problem in a more structured way. First of all, what is the problem in data science? Does anyone know about it? I often felt that the only problem is the availability of the data. We have huge amount of data and we really don't know what to do. Okay. So as we were hearing few of the product teams talking to us for possible AI/ML based solution, here is what we realized. The most important problem in data science is defining the problem itself. So let us now think of a specific use case, all right? So think of a statement that hotel guests say that the elevator is not meeting their expectation. So what's the problem over here and how do we solve this? The straightforward problem, maybe the elevator is too slow. And so we go for a complete engineering change with installation of new cables, upgradation of the motors, improve the algorithm, and make it a 6 months project. Okay. Now thinking of it differently, if I say that the problem is that the wait is too long for the people who are using the elevator, then another way to solve the problem would be to make the wait feel shorter. All right, so what do we do for that? We play music, we install mirrors, we install some gaming consoles and make the wait a bit more happier. So the learning here is define the right problem. So if you see the quote below, this is Albert Einstein, and see what he speaks. He says that if I had an hour to solve a problem, I would spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. So that is the importance of defining the right problem. And that's the same approach every data science team should follow. With multiple discussions with the stakeholders, we should be able to get a clarity on the question itself. What are we trying to solve? And not assume things as per our individual understanding or a generalization approach. Very, very important learning. Why? So let me give you another example, right? So think of the problem, connect the dots with no more than 4 straight lines and without lifting your hand from the paper. If you try to do this, you will realize that it is not an easy problem maybe. So I have given this problem as a thought exercise to my colleagues as well as a kid of 6 years of age. And surprisingly, the fastest solution was provided by the 6 years old. And I think that is because his mind was clear, and he did not complicate it by too many experiences of solving similar problems in the past. Well, this is the solution. So do you see over here? This line actually crosses over and connects only 2 red dots. So this is a bit different than what our thought process usually says. So the solution lies actually in the observation that it is okay to cross square boundaries. Often we impose restrictions that are not inherent to the problem maybe. To bring in the culture of structured thinking, we adopted certain frameworks and certain terminologies. So the most important terminologies we took up or we adopted were the framing and convincing. So framing is all about defining the right problem and setting the right problem boundaries, breaking down the problem and determining the analytics methodology to solve that problem. Some of the frameworks we adopted were the SCKQ, issue tree, and the approach maps, where SCKQ is a very important framework which talks of the situations, the complication, and the key question. So this is the technique to decide on the problem statement itself. Suppose someone is telling you a story, he or she will first set the context and then the climax of the story comes up, right? So we followed the same process for defining an AI/ML problem. We asked our customers to set in the context, which is the situation, hence come up with the need for the change, which is the complication, the climax of the story, And from this, the key question, the problem statement was derived. Okay, so then we used some issue tree, which was mostly used to break up the actual key question into simple solvable tasks. So in a nutshell, we divided and conquered the why part of a business problem with how in analytics. This is the structured approach we tried to adopt. Okay, so once we came up with some solution, we used the logic tree framework to communicate to our stakeholders on our findings. This is the convincing part and again involves a storytelling approach, all right? Perhaps now we understand why a data science professional needs to be a good storyteller, because everywhere there are storytelling in the process. So the key takeaways here are innovative thinking, out-of-the-box thinking, and the innovative solutions. Right? All right. So let me quickly go through our learnings here. So we have to start with the why, that's understanding the problem, and then go to the how, that is the solution. We have to craft a clear problem statement, which should be smart, which should be specific, measurable, action-oriented, relevant, and time-bound. We have to define the potential for solving that problem with analytics. So now I think we actually know where to start. So we start with the SCKQ, right? By defining the situation, complication, and the key question. And that's great. So another milestone reached. We have a structured thinking approach to business problem solving. What is our next step? Now, the third step, we now started defining the process across the different roles and responsibilities in the COE. So what do? Here is an overview of the important actors, the actions, and the artifacts which come out as a process. Okay, so the first important role is the project lead. He can be the business person or somebody who's very close to the business, who understands the actual description of the problem, creates a template repository, mainly for code check-in, etc., GitHub, Bitbucket, etc. It is very important to actually check in the labeled data set also, because labeled data set is rare and it is very important to keep a copy of that. Maybe not in the Git repository, but in some blob storage kind of a store. All right. So once he is clear about the business requirement, the next work is by the project manager, where the project charter is defined, which defines what is the use case that we are trying to solve and where the data sets available, the data dictionary, etc., etc. So once the project charter is defined, the data scientist actually sits with the data and explores the data and creates some kind of a data summary report. All right, so we come up with a data summary report, and in the meantime, the architect is actually designing the architecture, that is the data pipeline, which I talked of in the reference architecture. All right. So once the data summary report is out from the data scientist, we get to know whether at all any further analysis is possible or not, whether we do have the sufficient data or not with us. And in many of the projects, we actually truncated the further flow at this point itself when we figured out that no, we don't have the sufficient data, right? So suppose we are continuing, then the data scientist will sit with the data, he or she will do lots of model tuning and select the best model and come up with a model. He or she will provide the model report, which will explain how to use the model, what are the metrics which we need to follow to figure out how the model is performing, and how to create the dashboard, etc. And finally, the model is deployed. We check in the final artifacts and the final project report we come up with, and we close the project. So that is what we slowly started following. So it may not be this simple, but let us not complicate this with further understanding of the complexities part. Okay. So what were our learnings? So in the entire process, we learned that we should and we must have a weekly client meeting and checkpointing, as it is very important to have a similar mind share between the clients and the development team. Okay. Otherwise, everything comes as a surprise to the end of the process. Why it is so important in data analytics is particularly because the client, in the initial stages, it is like a black box to them. So they don't understand what data science is doing. Slowly, when they see the progress, they come to understand what all difficulties we are facing, and they also become much more flexible. So they start giving us more, labeled data. They start interacting with us with more business feedback, etc., etc. So we evolve over time. We start building better and better solutions. So that's why the client interaction is very, very important with data analytics projects. Okay, so the last thing I would like to cover is how we ensure quality in AI/ML solution. I will not go into much details in the interest of time, but I just wanted to bring in the idea of how AI/ML testing was a challenge and how it was different from the conventional product testing. Let us proceed. So the unique challenges in AI/ML testing lies in the fact that AI/ML development and delivery practices are different from the regular product delivery. It is important that we understand these basic differences. For example, think of the features. We can clearly commit to deliver a specific feature with a specific accuracy level in a software product. What do? We can define some if-else statement in our code, put some algorithmic logic to give a very, very deterministic outcome, right? But AI/ML solutions are non-deterministic. It is not a 0-1. It is like fuzzy kind of output, all right? So the accuracy of ML algorithms mostly depend on the quality of the underlying data, whereas the accuracy of the software products depend mostly on the skills of the software developer. So that's a very fundamental difference. So we completely depend on the data. The other difference would be in the continuous learning process of AI/ML solutions. So AI/ML models are first put into production and they self-learn over time as they gather and train more and more relevant data from production. This is an important difference, which is not very intuitive maybe, but it often motivates the AI/ML team to come up with unique testing strategies. So the punchline is effective quality assurance now demands data analytics technology understanding, the domain, the AI/ML domain understanding, along with the business understanding, which the testing team normally has. So basically the idea is to raise the bar with continuous testing through multiple iterations of AI/ML modeling with new data and clarification in the business understanding. All right, so to remember, the testing is not confined here to just testing the final solution. Testing team gets engaged with the data science development team across all the 5 stages of development lifecycle of the AI/ML models. And I have captured here all the detailed testing, which is followed in each stage, and we can discuss over hours in this. But I will not cover this in detail, but for the sake of completeness, I have included the last 2 slides, which define the quality engineering process from a typical AI/ML solution perspective along the 5 stages of the reference architecture. So if you see over here, just I will cover one, maybe the data ingestion part. Here we have to be focused on correctness, appropriateness, completeness of the source data in large volume, velocity, and variety. We have to be concerned about the security and the compliance in storage with respect to HIPAA and GDPR guidelines. So what do? We do in testing is data quality checks, transformation checks, format checks, lineage, pattern checks, privacy checks, etc. And we have to be ready with sampling, aggregation techniques, and design the right data storage systems. All right, so these are the things which we actually test. So that concludes the presentation, and I hope that I was able to convey the burning challenges we faced in bringing up the AI/ML COE in the organization, where we started and how we started rather, and how we defined the best processes to solve a problem, ensuring the best quality. It was an experience of a lifetime for me, and I'm really happy to share with you that experience in this platform. With that, I would like to thank every one of you again. Thank you so much for joining in and listening to me. And I'm open to questions, if any. Thank you so much.